Hello everyone. So last week we looked at fluid mechanics, and this week we'll be looking at chapter 6, which will be thermal energy and thermodynamics. The name sounds scary, but it's actually most of these things are very you guys are very familiar with. We're going to look at things that have to do with temperature, hotness and coldness, and all the things that surrounds temperature and absolute zero. So you're going to look at it as we move forward. Um, so what we actually want to study from this, we want to understand temperature, and you're going to see a new concept. Probably it's a new concept to you guys, that will be absolute zero. We'll be able to see what absolute zero is and what happens at absolute zero. Now, when we talk about temperature, generally it's always relative. If we say that an object is hot, then we must be comparing that object to a different object, and in a sense we are saying that this object is hot relative to this object because this other object is cold. Now what we are saying is that if we say object A, like this object is cold, sorry, then we're going to say this object is cool relative to this object because this other object is hot. So when we talk about measuring the temperature, then it must be relative to something. Like it said, a stove is said to be hot to have a high temperature, and an ice cube to have a low temperature. An object that has a high temperature than another object is said to be hotter, or the other object is colder. So there must be this relative idea that has to come into play when we are looking at the degree of hotness or the degree of coldness of two different bodies. They must be relative. So we can also, it's possible for us to be able to measure temperature using the sense of touch. It's possible for us to touch an object and we are able to decide if the object is hot, if the object is cold. But however, this temperature senses somewhat, it's generally unreliable because we cannot actually pinpoint, we cannot actually say that, okay, this is the temperature, maybe it's 70 degrees, or this is the temperature if it's 30 degrees, or whatever the case. And it's because of that where scientists had to come together and see how they can be able to make an instrument or produce an instrument that can be able to give us accurate measurement as to what temperature is for a particular body. And the instrument that is generally used to measure temperature is what we commonly known as a thermometer. A thermometer generally changes, it's a property of a substance. It changes with temperature. So for example, if the temperature of a system is cold, the thermometer changes, it has that property to change the temperature relative to that particular object. For example, if it's cold and if it's a 40 degrees or whatever, the thermometer has that property to indicate that the temperature is 40 degrees, or maybe the temperature is 70 degrees, or whatever the case may be. And there are various kinds of thermometers. We have the clinical thermometers, we have bimetallic strip thermometers, we have liquid in glass thermometers. There are just so many different thermometers that have been made in order to be able to measure temperature, and all of them have different properties. Some of them, the volume they use the property of the volume. Some of them use the property of current. Some of them use different properties to be able to measure temperature. And so what happens is that if we are considering like the mercury type of thermometer that the solid or the liquid or whatever the case may be is mercury or alcohol, then what happens is that the temperature generally is the measurement of the expansion of that particular liquid, if it's alcohol, or solid if it's mercury. So the expansion of that liquid tells us the temperature. When we get the reading from the thermometer, it's able to tell us what the temperature is at that particular point. So therefore we can also say that reading occurs when the thermometer and the object reach thermal equilibrium, having the same average kinetic energy per particle. Now I think this is an idea that is mostly familiar, you guys already are familiar with, so I'm going to move ahead. So now, one thing that we must understand generally is that when we are talking about temperature, we have to also consider the motion of the atoms or the individual atoms of that particular particle. Now, for example, if you look at the first case, we have an atom of gases. We have an atom, and we have, sorry, a particle or a molecule. It has two atoms. And the motion that these two particles can undergo is a translational motion. It means those two particles can actually move. They can move from one place to other. This can move to this point, this can move to this point. So we have a relative translational motion that exists between those two atoms in that particular molecule, and so to this other atom, and so to this other atom. In this case we have a vibrational motion. In this case, we have a rotational motion. In this case we have a vibrational motion. And basically these are the three states of matter we talked about when we're looking at fluid mechanics. These gases, they are so far apart that they can move from one end to another, so they exhibit what we call translational motion. For a liquid, well, they are not very far apart, so they can rotate around each other, so they exist what we call rotational motion. And the solids, generally, since they are very close together, they can only vibrate around each other. And as a result of that, it's possible for us to measure the average kinetic energy of these particles, how they are translating, or how they are rotating, or how they are vibrating. And the measurement of this average kinetic energy that exists between molecules or atoms in a particular molecule, we can be able to determine the temperature of that particular atom. So it's possible. So temperature is proportional to the average translational or kinetic energy per particle that makes up a particular substance. So we're going to stop here, and then we're going to continue in the next video.